This is a video about how to make a velocity graph, a velocity time graph from a car speedometer. So this is a 2013 Prius. I'm in Minnesota. I'm going to floor it, legally. I'm going to turn left onto a Minnesota highway, and then when I get to about 60 miles an hour, I will let off the throttle. So here's what the video looks like. So you can see the information is the speed, it's digital. And I also have timestamp information from the video. All right, so it's not a lot of data. So you don't have to import this into LoggerPro, but I'm going to. So I'm going to close this window. I'm going to switch into LoggerPro. And as before, I'm going to insert a movie. So we've done this already in class. Opening movies in LoggerPro is real hit or miss, but this might work. So here's 221, here's Prius. And depending on the size of the movie, it seems to be slower or faster to open. So the data that I've got inside of the Prius as soon as it opens up is going to be speed from the speedometer and time from the video. Okay, so that took about 20 seconds. So now it's finally open. So here I am with my daughter. My daughter's holding the camera. And in a little bit, we'll be starting. Okay, so there's some initial data. So 0 miles per hour. So let me step forward frame by frame with this button. Okay, so I start moving at a timestamp of 2.307. So the nice thing about LoggerPro is if you don't want to do any collection with their devices, you can still enter the data in a spreadsheet. So this is going to be time, T for time, and the units will be seconds. So this is the video camera's time. And this will be speed. We'll call it V in miles per hour, and we'll have units of miles per hour. So at 2.307, I have a speed of 0, and you can go use tab to go back and forth between the two data fields. If I make this a little bit bigger, then it won't give me so much trouble, maybe. All right, there we are. So I made a long graph with a lot of data points in it, and that was kind of a drag. So I'm not going to do that in front of you. But let me just show you how I took data. So here I am. So let me fast forward. Now I've got 2 miles an hour, and that happened at 2.340 seconds. 2.340 seconds. I've got 2 miles an hour. Now there's different approaches to how to take this data. I could take every single frame, but that would be a lot of typing. So the speedometer just tipped over to 4. So that means that 2.640, I'm at 4 miles an hour. And I keep going. Now I'm at 6 miles an hour. That happens at 2.907, 6 miles an hour. So you can imagine that I just step through the video, and whenever I have a speed change in the speedometer, that means, oh, I just reached that speed. So now I'm at 3.207 and 8 miles an hour. So you can see from the graph that I've got this nice data set. What's happening in this graph? As time goes on, my speed is increasing. So if I just fit these data points, you see that initially I have a speed of about 7 miles per hour per second. That's how speed changes. That would be my acceleration. So about 7 miles per hour every second. I've got a much better graph. Let me pull that up. All right, so here's the data, and what I did is I went through the video and I recorded the time that I started to see a speed, so the time that I started to see 30 miles an hour, and also the time when 30 miles an hour disappeared. So 30 miles an hour appeared at 6.573, and 30 miles an hour disappeared at 6.840. So in some sense, that's an uncertainty. So somewhere in between those two data points is where the car was moving 30 miles an hour. So for every record in the plot, so where are we at? 30 miles an hour. So there we go. So see how there are two records where you're going 30 miles an hour? So you can see that that's kind of like an uncertainty or an error bar. So the real motion of the car is in between those pair of points. Now, I don't expect you to do this many data collection points with the data you have in class. That would just be, ridiculous. So, just pick 5 or 6 that characterize the behavior well. You might notice that these points right here are real high. I think I had tire spin or wheel spin when I was starting. You remember I was going around a corner and the speedometer kind of jumped. I don't know if it was icy or whatever. So this isn't real. And I think the Corvette that I asked you to analyze has some of the same behavior. Okay, so what math model describes... So if I highlight a whole bunch of points like this, straight line fit button, so you can see a straight line kind of describes what's going on here. You could say that the slope is about 6.5 miles per hour every second. That's how I'm speeding up. The car is speeding up when I'm initially going like less than about 30 miles an hour. When the car is going highway speed, I just use the eco button, so maybe I can accelerate better than this. But here you've got a math model where the speed is about 3 miles per hour every second. So that's the high speed acceleration and the low speed acceleration. Now, miles per hour per second is a nice unit. I know what it means, but it's not the normal physics unit. So if I wanted to convert the units, what you can do is create a calculated column. So under data, you can create a new calculated column. This will be the speed as well. And I'm going to give it the name V meters per second 2, because it's meters per second squared. And the units are going to be meters per second squared. Now, how do you specify the conversion? So I want to take V, so that's the miles per hour V, and I need to move from miles per hour to meters per second. So let's see. There are 10,000 meters in every 6.2 miles. And in 1 hour, there are 3,600 seconds. So if I include a multiplication sign here, I think this conversion, so 10,000 over 6.2, convert into meters, and 1 over 3,600 to convert into seconds, I think that will give me, oh, but wait a second. Do I want meters per second squared? No, I want meters per second. I was thinking of the slope and not the actual value. So if I have miles per hour and I want meters per second, does this make sense now? V is in miles divided by hours. And so this takes care of hours into seconds. And this could, yeah, I think that's going to be okay. All right. So if we hit return, what do we get? Let's check our work. If the miles per hour speed is 11, the meters per second speed is 4.928. Does that make sense? Let's Google it. Okay, I opened up a web browser and I Googled 11 miles per hour in meters per second. It's 4.91 meters per second, so I feel good about my conversion. I must have done it right. All right, So what does that graph look like? So let's insert another graph. There it is, speed in meters per second. I mean, it's the same kind of thing. It's just plotted with different units. So my two slopes, of course, I could do this analytically. The low speed acceleration is about 2.9 meters per second squared. Gravitational acceleration is about 10. So the Prius is actually quite fast at low speed. The high speed acceleration is what? About 1.3 meters per second squared. So that's, like 1.5 Gs. No, 15% of G. So that's not a big acceleration at high speed. And when you drive a Prius, you realize that. I mean, that's kind of how the car drives. All right. So now the question is, how far did the car go? I'm not going to use LoggerPro to do that. I'm going to use a program called Microsoft Excel to figure out how far the car goes. That'll be in the next video.